Hello friends, today we are discussing about the transportation problem. So transportation problem is a special kind of linear programming problem in which goods are transported from a set of sources to a set of destination subject to or according to the supply and demand of the source and destination, such that the total cost of the transport is minimized. So, the ultimate aim of transportation problem is to minimize the transportation cost. Now, we'll see the types of transportation problem. There are two types of transportation problem. The first one is balanced transportation problem and the second one is unbalanced transportation problem. If the supply is equal to the demand, it is called balanced one, and if the supply is not equal to the demand, it is called unbalanced. To solve a transportation problem, all the problem has to be balanced. That means supply has to be equal to the demand. If it is not like that, we have to make it as balanced by adding a dummy row or column according to the situation. Next, we'll go for the methods of transportation problem. The transportation problem can be solved by two phases. The first phase is finding the initial basic feasible solution, and second phase will be the finding the optimization. By these two phases only we can solve a transportation problem. Now we'll see an example of transportation problem, and here we'll write the sources and here come the destinations. A, B, C are called the destinations and 1, 2, 3 are called the sources. And we can see demand here, and this is the supplies. Each row having a supply and each column having a demand. Before going to solve a problem, we have to see the problem is balanced or unbalanced. For that, what we have to do means we have to add all these supply. 200 plus 300 plus 500, it is 1000 only, and for the demand it is 200 plus 400 plus 400, it is 1000. So the supply is equal to demand. So that is, this problem is a balanced problem. So we can go for the further phases. For example, if it is not balanced, that means supply will be more or demand will be more, like that situation, we have to make it as balanced by adding one more dummy column or dummy row with 0 value to make it as balance. After make it as balance, then only we can solve this problem. The first phase to solve a transportation problem is to find the initial basic feasible solution. For that, there are three methods. First one is northwest corner cell method. Second one is the least cost cell method, and third one is VAM method or Vogel approximation method. We'll go through all. Now we'll start with the first method. It is northwest corner method. So here come the transportation table, and the elements of the matrix value is already written, and these are the supply values, and here we'll written the demand values, and the origin and destination already mentioned. So each cell value has its own supply value and the demand value. So the first step for the northwest corner rule is identify the north element in the given matrix and allocate as many as possible. So before solving the problem, we have to find out it is balanced or unbalanced. For that, what we have to do means we have to add the supply values. That means sigma supply we have to find out, and we have to find out the sigma demand also. So both the supply and demand equal, then only the problem is balanced, then only we can go for further steps. For that, here we'll find out 5 plus 8 plus 7 plus 14, it is 34, and the demand value it is 8 plus 8 plus 18, it is 34. So that means sigma supply is equal to the sigma demand. So we can go for the solution. Now we'll go for the steps. The first step is we have to find out the north element in this matrix. So here this is a north element. So what we have to do means after finding the element, we have to check the supply value and the particular demand value. Then we have to allocate which is the minimum value. So here the supply is 5 and the demand is 8. So 5 is the minimum value. So we'll allocate the value 5 in the first cell. That means in the origin O1 and destination D1, and the cell is 2, we are allocating the value 5. After allocating the value, we have to subtract the allocated value with the supply value. So 5 minus 5, now it will be 0, and here 8 minus 5 will become 3. And here we are getting supply 0, so the particular row we will cancel. This is the first step. Then we are getting the remaining problem. In that, next we will find out next north element. So here next north element is 3. That means origin O2 and destination D1, and the cell value is 3. Again we will check the particular supply value and the demand value. Here it is 3 and here it is 8. So which is the minimum value? That is 3 itself. So what we'll do? We'll allocate 3 on this particular cell, and this allocated value 3 minus 8 minus 3, so that now it will be 5, and 3 minus 3 will become 0. So now we are getting 0 on this particular column, so we'll cancel this particular column. Okay, then next, this much only our problem. Now here again, which is the north element, this is the 3. So again we'll check the supply value 5 and demand value it is 8. So the minimum is 5. So we'll allocate the value 5 over this cell. 5 minus 5 it is 0, and here 8 minus 5 become 3. Now we got supply value 0 here. So what we'll do? We'll cancel this particular row. Now only this many elements are left, and from here again we have to find out which is the minimum value, north value. So it is 4 only, and here we can see 3, and here will come 7. So the minimum value is 3 itself. So we are allocating 3 over here. 3 minus 3 it become 0, and 7 minus 3 it will become 4. So now we got in this particular column 0. So we will cancel this particular column. Now remaining these two elements 7 and 2, and here we'll allocate the first cell 7, and the values are 4 and 18. So the minimum value is 4. So we will allocate 4 here. 4 minus 4 become 0, and this element will cancel. So here 18 minus 4 it is 14. So now we are having only one cell value, that is 2, and the supply value for this particular cell is 14, and the demand value is for 14. So we'll allocate, both are equal, so we are allocating 14 itself. 14 minus 14 it is 0, and here 14 minus 0 become 0. So our all the elements we allocated. Now allocating all the values, we will enter in this table. Here in origin O1 and destination D2, the value we allocated is 5. So here origin O1, destination is D1, and the number of unit we allocated is 5, and the cost of the cell is 2. So that is 5 into 2 is 10. Next, in the origin O2 and destination D1, the number of unit we allocated is 3, and the cell value is 3. So that is 3 into 3. So O2 D1, number of units allocated is 3. 3 into 3 become 9. Next, in the same O2, destination is D2, and the cell value we allocated is 5, and 5 into 3 it become 15. Next, in O3, the value we allocated is 3. 3 into 4 become 12. Again in O3, destination is D3, and 4 into 7 become 28. Next, in O4, the value we allocated is 14. 14 into 2 become 28. So finally we have to add all the values. 10 plus 9 plus 15 plus 12 plus 28 plus 28, it is 102. So the total cost we got is 102. The solution for the problem is 102 rupees. We'll go for the least cost method. Here we'll show the transportation table, and each element of the matrix indicate the cost in rupees, and here we can see the supplies, and here we can see the demand values. So before solving the problem, we have to find out the sigma supply and sigma demand. Both has been equal, then it is called a balanced transportation problem. Then only we can go for the further steps. And for that, we will add all the supply values. 5 plus 8 plus 7 plus 14, it is 34. So the sigma supply is 34. Then we'll add all the demand values, 8 plus 8 plus 18. So that means sigma demand also it is 34. So the sigma supply is equal to sigma demand. So we can go for the next procedure. In the least cost method, the steps are: identify the least element in the entered table and allocate to it as many as unit as possible. So in the entered elements, we have to find out the least elements. So here we can see, here is the least element 1, and here again the element is 1. So any one we can find out. So here it is 8 and here it is 18. Demand is 18 and supply value is 8. So which is the minimum? 8 is the minimum value. So we are allocating the value 8 on this particular cell, and 8 minus 8 become 0, and here 18 minus 8 become 10. So we got supply 0 for the O2, and so we can cancel this particular row. Okay. Next, from the remaining elements, next we have to find out again the least element. So it is 1 itself, and here you can see the demand value is 8 and the supply value is 14. So the smallest one is 8. So we will allocate the value 8 over here. So 8 minus 8 becomes 0, and 14 minus 8 becomes 6. Next, here will come 0. So we'll delete all these values. Next we'll find out from the remaining cell which is the minimum value. So here it is 2 is the minimum value, and here you can see 6, and here you can see 10. So 6 is the minimum value. So we'll allocate 6 over here, and 6 minus 6 become 0. 10 minus 6 become 4. Now we got 0 in this particular O4. So we'll cancel all these elements. From the remaining elements, that means 7, 4, 4, 7. So the minimum is anyone we can select, any 4, this or this we'll select this 4, and here we are getting 5, and here will come 4. So 4 is the minimum value, so we'll allocate 4 here. And now 4 minus 4 become 0, and here 5 minus 4 become 1. So here we got 0, so we cancel all this column. Now from the remaining, we'll see the elements remaining is 7 and 4. And from 7 and 4, the smallest element is 4, and here the value is 7, and here is 8. So we'll allocate 7 here. 7 minus 7 becomes 0. 8 minus 7 become 1. Now only one element is, so here again 0 is coming, so we'll cancel this one. And now only one cell is pending, it is here in O1 and D2. The cell value is 7 and the supply value is 1, and here the demand value also, both are same only, so we'll allocate here 1. 1 minus 1 becomes 0, and here 1 minus 1 becomes 0. So now we allocated with all the getting, we will find the total cost. It is 1 into 7 plus 4 into 4, 8 into 1 plus 7 into 4 plus 8 into 1 plus 6 into 2. So 7 plus 16 plus 8 plus 28 plus 8 plus 12, it becomes 79. So the total cost for the transportation problem is 79 rupees.